back again for quiz 2. So question A is these two lines here are given, and we need to find out whether they're parallel or not. Now, we don't really need to worry about these values, but what we are looking for is the coefficients of x, y, and z. So for L1, the coefficient of x is 1 over 3, and the coefficient of y is 1 over 4, and the coefficient of z is 1. And so for L2, the coefficient of x is 1 over negative 6, y is 1 over 8. Sorry. Oh yeah, sorry. Negative 4 for the y here. And z is also 1 over 2. Negative 1. So, with all those little errors aside, what do we notice here? If we multiply this by negative 2, we get this. And therefore, the lines are parallel. B, vector blah is orthogonal to blah. I'll just write up. So, here's the thing. If we have this plane is 2x minus 2y plus 4z equals 8. So, by the definition of a plane, the orthogonal vector is going to be the coefficients of these three numbers. And so the vector here would be 2, negative 2, 4. But the vector given is 1, 1, negative 2. Now, not only are these not the same, they're not even multiples of each other. The negatives don't line up. So, no, B is wrong. That vector is not orthogonal to the plane. Now, for question C, it gives the equation from a point to a plane in a completely wrong way. I'll just write down the actual equation. But yeah, C is wrong because the equation is totally wrong. Yeah, the distance from a point to a plane, so this is a vector between a point on a plane and a point not on a plane, and this is the normal vector to the plane, over magnitude of the normal vector. Or you could use the equation ax plus by plus cz plus d over square root of a squared plus b squared plus c, which is still not the same as the equation given in C. So, for the final question, we have two planes. And we are back for question 1D because I messed up the planes equations the first time. So the question is, we have two planes. Plane 1 is x plus y minus z equals 0, and plane 2 is x plus 2y plus 3z equals 6. Are they orthogonal? So we're going to figure this out by taking the dot product of both of them. And if the dot product is 0, then they are orthogonal, and if it's not, they're not. So let's go to it. So 1x plus 1y minus 1z dot 1x plus 2y plus 3z equals, so we get 1 and 1, 1 plus 1 times 2 is 2, plus negative 1 times 3, which is minus 3. And would you look at that, 1 plus 2 minus 3 is in fact 0. So yes, they are orthogonal, and question D is correct. And the last one, E says none of above, which is clearly not true. So E is also false. Alrighty, so moving on to question 2. I've already written out the solution because I really did not feel like writing it all out in front of the camera. So here we have the question, limit t to 2 of rt minus u over t minus 2 is 12i minus 10j. Now looking at this, this is the definition of the derivative, which means that r prime t at 2 is 12i minus 10j, or 2 comma 10 if we want to do it in a different type of notation. And because of the definition of the derivative, u is actually our at 2. So that means that our t at 2, but that's, what we're actually interested in here is 8I minus 10j. I'll just change this real quick. It's R1, 2, R prime 2, R2. Yeah, so that already gives us half of all the components we need. Now, because we're dealing with chain rule, we're looking for the derivative of tangent pi t over 8 times rt. And because this is the chain rule, we're also going to need to find both the tangent and the derivative of the tangent at t. So tangent of pi t over 8 at t is 2 is going to be tangent of pi over 4, which is 1. And the derivative of tangent of pi t over 8 is pi over 8 secant squared pi t over 8. And if you plug 2 into there, you get pi over 8 secant squared pi over 4, which is pi over 8 square root of 2 squared, which is pi over 4. So now we have all these components. Let's move on. The chain rule tells us that the derivative of this is going to be the derivative of tangent times rt plus tangent times r prime t. And now all we need to do is fill in all those values we've already found. The derivative of tangent is going to be the value is going to be pi over 4 times rt, so 8 comma negative 10, plus just tangent 1, derivative of rt 12 negative 10, and then we just do algebra. 8 comma negative 10 multiplied by pi over 4 is going to be 2 pi comma negative 10 pi over 4, and then 1 times 12 comma negative 10 is still going to be 12 comma negative 10. Then if we add that up, so we add the two x components here, x, and the two y components, we get 2 pi plus 12 comma negative 10 pi over 4 minus 10. And if we're going to put these all into one nice fraction, we end up with 2 pi plus 12 minus 10 pi minus 40 over 4, which is in fact answer B. And so that's why answer B is correct. And since answer B is correct, everything else must be wrong.